Hello everyone, let me introduce myself to you. My name is Prasan. I am from the third semester data science. Today I am going to explain you about the CPU scheduling via FCFS. CPU scheduling is one of the most important functions of an operating system as it determines how processes are selected for execution by the CPU. Efficient scheduling improves overall system performance, reduces waiting time and ensures better CPU utilizations. Among various scheduling algorithms, first come first serve is the simplest and most fundamental technique. FCFS follows a straightforward approach where processes are executed in the exact order in which they arrive in the ready queue. Similar to a standard FIFO system, although FCFS is easy to understand and implement, it has limitations such as higher waiting time for shorter processes when long processes arrive first, commonly known as the convoy effect. This assignment focuses on understanding the working of the FCFS algorithm, implementing its logic through a program, generating the Gantt chart, and calculating performance metrics such as waiting time, turnaround time, and completion time. The objective of this study is to analyze the efficiency of FCFS and evaluate its overall behavior when handling multiple processes with a different arrival and burst times. And next is the experimental setup. The experimental setup for implementing the FCFS scheduling algorithm involves preparing the necessary environment, tools, and process inputs required to execute and analyze the scheduling mechanism. The experiment is conducted using a programming environment capable of handling user input, performing arithmetic calculations, and displaying the results in a structured format. The system concepts predefined arrival times and burst times for each process, which serves as the core inputs for evaluating the scheduling behavior. A suitable compiler or interpreter such as Python, C, or Java is used to run the program that simulates the FCFS algorithm. Here we have used the C program with the hardware configurations of Intel i5 12 generation 16GB 512GB SSD, system configurations with Windows 11 64-bit, language is C, and processors ID, arrival time, burst time, completion time, turnaround time, and waiting time. And next we will move on to the implementation steps. The implementation of the FCF's scheduling algorithm involves translating the theoretical concept into an executable program. The program begins by accepting the arrival and a burst time of processes and arranging them in the order of arrival. It then calculates the various performance parameters using sequential execution logic. As FCFS is a non-preemptive technique, the Gantt chart is generated based on the execution order, visually representing how each process is scheduled. The implementation ensures that the algorithm's flow is followed accurately and all calculations reflect the true behavior of FCFS algorithm. Here you can see the input and the process of sorting and calculation times and average times. And next we'll move on to the observations of this. Based on the output obtained from the FCFS implementation, it is observed that the algorithm strictly follows arrival order, which can lead to varying waiting times among processes. Short processes may experience longer delays if they arrive after a long process. The Gantt chart visually confirms the sequential behavior. The average waiting time and the turnaround time reflect the scheduling process and sequence, and the results clearly align with the theoretical characteristics of FCFS. These observations emphasize the importance of arrival order and its direct impact on scheduling efficiency. Here you can see in the observations, waiting time depends on arrival order. In FCFS, the first process gets the CPU immediately if it has arrived. Later process must wait for all previous process to finish, so waiting time increase for late arrivals. It causes convoy effect. If a first process has a long burst time, it delays all other process even if they have shortest burst times. This increases average waiting time and turnaround time. CPU idle time. If no process arrived at, CPU stays idle until first process arrives. Property based arrival times can reduce the idle time and improve efficiency. Average time waiting and turnaround time. In the FCFS is easy and fair. If bus times are similar, FCFS works well. Next, we will move on to the comparative evaluations. Comparative evaluations focuses on the analyzing the performance of the FCFS against theoretical expectations and assessing its efficiency in different scenarios. By observing the calculated waiting times and turnaround time, the impact of process arrival order becomes evident. FCFS performs well when processes arrive in order or have similar burst times, but it becomes inefficient when long processes arrive before short ones. This comparison highlights both the strengths and limitations of the algorithm, demonstrating how scheduling decisions influence overall system performance. Here you can see in the comparative evaluations, the FCFS works differently for different data sets. Long first process increase waiting time while evenly burst time keep waiting time low. Like here the example, process 1, process 2 and process 3, arrival times and the burst times. In the process 1 arrival time is 0, burst time is 4. 2 process 2 is arrival time 1, burst time is 3. In the process 3 arrival time is 2, burst time is 1. It moves with the order P1 to P2 and next P3. With the process 1, 2, 3 arrival time it is 0, 1, 2. Burst time is 4, 3, 1 and CT is equals to 4. Next for the process 2 is 7 and 3 is 8. We will calculate the average time and waiting time and average turnaround time with the TAT. With the sum of the TAT we will calculate the average turnaround time. With the average waiting time we will calculate average waiting time. Here you can see uh, the 466 the average turnaround time is 5.33 and the waiting time is 2.67. And next is the code structure. Here you can see I have written the code in this manner, but you can see this structure well in the its compiler only. I have done it in the Dev C++. Here you can see the ash includes today.h. These are the uh, libraries which I have called for this. Here you can see the code. I have created the different voids for this: sort by arrival, calculate FCFS, display results, and int main, int num process. Here the actual code starts from here. Okay, next. Before the conclusion, we will run the code and we will see the output of it. Let's run this code and see the output. Here you can see the code is successfully run without the errors. We will add some 3 processes here. We have to add a process ID, arrival time, burst time for each process. We will add a process ID as 1 and arrival time we will add uh, 1 for it, and the burst time is also we will add a 2 here. Okay, next the process ID will be 2 and the arrival time will be 2 and the burst time will be 4. And next for this is a process ID is 3, arrival time is 0 and the burst time for this is 5. Here you can see the arrival time for this is low, means it came first because it has the 0, so it will be the first. Now we will run give the enter for this. Here you can see the process P3 it came first because it has arrival time 0 and P1 is 1, P2 is 2 and its burst times 5 to 4 and the completed 5, 7, 11, turnaround 5, 6, 9 and waiting 0, 4, 5. Average waiting time 3, average turnaround time is 6.67. Yes, the code is run successfully. Next we will move on to the conclusion parts. We will move on to the conclusion part. Here in the conclusion, the FCFS scheduling algorithm provides a simple and a direct approach to process scheduling in the operating systems. Through this assignment, the algorithm was successfully implemented and all key performance metrics were accurately calculated. The analysis revealed that while FCFS is easy to understand and implement, it is not always efficient for systems requiring optimized response times. The convoy effect significantly affects performance when process arrival patterns vary. Overall, the assignment enhanced understanding of CPU scheduling behavior and demonstrated the practical implications of scheduling decisions. Here, the first come first served scheduling algorithm is one of the simplest, easiest scheduling methods, but it executes in the first come first served manner, though it is not efficiently when all processes have similar burst times, as waiting times remain low and the CPU is used efficiently. So it can delay all the process, leading to higher average waiting and turnaround times. Though FCFS is a simple and affair, but it may delay later processes if burst times vary. It is not suitable for real-time systems where tasks need quick executions. Thank you, everyone.